Oh, it's 9:30.
Yes.
All right. Well,
We start.
I think we should give people a couple minutes. It's pretty sparse. Let's see if we at least have our speakers. It says 1, 2, 3. Is Michael here?
I saw Michael there.
Where's Michael?
Yeah, talking with Anna.
Oh yeah. 4. The Etherpad. If you go to the main, you go to the main IETF 97 page. It's got the hotel links and all that stuff. There's an HTMLized agenda linked off that page. And you'll look for the little light bulb icon next to the meeting. Oh, I'm sorry, the Etherpad is next to the Jabber icon.
Yeah.
That's, if you find the TAPS one, just hover over each of the icons, you'll find one that says Etherpad. You follow me? That's all right.
I can go in here. Yep.
Somewhere. Nope, that's not it. Here, Kyle, look. Are you looking? This one here. Noted. Well, it's about time to get started. Is anybody here aware of somebody we should be waiting for? Okay. I think we got all the presenters here.
Okay. Yeah. So then, let me welcome you all, me and along with my co-chair, Aaron Falk. Welcome you all to the STAPS Working Group IETF 97 meeting. And here for your information, must have the obvious. Note well. I hope you read it, you follow it, and you understand what it is. So next slide. So
You are? Oh, you mean Jabber? Colin. He took a sticker.
So we have Colin and a JavaScriber, and we have Kyle and
Jake.
Kyle and Jake and an note taker. And
Yeah.
I would like
So-
to thank you for your services.
Yeah, comment about our note takers. They don't know anybody else in the room. So please take the time to give your name and don't assume that they know what you're talking about. So have some sympathy for the note takers.
So the blue sheet should be on the way. Yeah, say your name clearly. And blue sheet's on the way, and we have Java subscriber, note taker. We're good to go, I think. So this is the agenda. It looks like. Basically, we have the chair slide that's going on, perhaps, and then basically we have a short update from Michael Wills about these TAPS transport users, and we have Sten will give us update on this TAPS min set. And then we have Colin presenting these real-time applications, what it means for what is actually need for from a TAPS kind of service. And then you have very interesting talk from Tommy Apple about this moving beyond sockets and architectures and observations. And then on the 6th, we have Brian Trammell talking about post sockets. And finally, we have TAPS. Lead projects updates for the TAPS. I mean, they have been working on implementing TAPS, so good to have their updates. Yeah. So moving on, next slide. Status. So as we know, we have 3 documents. Good information is like the TAPS transport is IG evaluation state, and it has been scheduled for telechat, I think, 1st of December this year. Then we have adopted transport, Fairhorse, Gori Fairhorse transport, TAPS transport uses UDP drops. So it becomes an IETF, TAPS transport uses UDP, and TAPS working item. We have, I think there was some discussion in last IETF meeting, and we have asked the question on the mailing list, and there was no objection, I think. So we adopted that one. And then we have this, we have update from, I think we'll learn more about that one on these transport users. So when I did the diff, I think it was, the SCTP was included. And we have some related documents. Obviously, one of the important one was like minset. So it has been updated to reflect the changes on the transport users 02 version. And then we have these TAPS low latency service draft. It has been submitted pretty recently, and I think Colin is going to talk about that. And we have TRAML post sockets. That's kind of like we'll have a talk about that. But TRAML, you didn't include a TAPS in it, so I hope you still mean this is targeted for TAPS, so it doesn't end up in our. Let's discuss that. Okay, but we're assuming it was like you circulated in the mailing list. So next slide, please. So
okay.
Let's, yeah.
So we're tag teaming this morning. You know, so we have 3 milestones in this group. Let me sort of jump ahead to the next slide. This is a little bit better framing for the discussion. So we have 3 milestones for this group. The first one was to do some analysis of transport protocols to try to come up with some abstractions that could be useful for the TAPS API. And we're mostly done with that. I mean, there's still some work that needs to be done, but it's more editorial than analytical. The second step was to try to, out of that large set of features and services that are represented by the IETF transport protocols, to try to identify what the minimum set should be that that a TAPS API should support. The idea here is to make it sort of a useful subset. Where there's actually some benefit from having the abstraction on the API as opposed to something that's protocol specific. And we're sort of in the middle of that now, right? We're talking about minset, and we've got a rather, the minset draft, if you've read it, is on the, not that minimal. And then the third step in the working group is to start talking about mechanisms. Specifically how to select and engage a particular protocol, how to see if it works end to end, and the talks today. We've got a couple of talks today about some different implementation strategies, and so I think we're just starting to move into that part of the discussion. So let me just sort of put a slide here. This is a placeholder for a discussion I think that we want to have later on in the meeting. I'm not trying to have it now, which is that the draft guessing TAPS minset is a sort of a bottoms-up analysis that applies an algorithm that we've talked about here to come up with a set of services, and then with the draft from Colin. We're taking sort of a top-down look at what applications actually need, and so it might be that we can prune this the list of stuff in minset down somewhat to which I think may make it somewhat more useful or possibly easier to implement. But that's a discussion I think we want to have today, and if we can move through the various presentations, I think we'll have time towards the end for that.
I think we'll be having at least 5 minutes, because I looked into the agenda and it is actually 85 minutes. So yeah, if we go through this, go through the slides presentation as planned time, so you should have time.
Okay, so yeah. So in summary, usage draft is progressing. The thing to do now is to focus on nailing down minset. And at the same time, we can start talking about some of the mechanism. So, Stein?
I think
No?
you should
I have the wrong order here?
Yeah, Michael's slide first. Michael's presentation first.
Right. It didn't. Did I misnumber these? Oh, there's one missing because it's PowerPoint. Got to be different. I didn't try to do this thing. Do you want to? Let's see if this just works. Oops. There you go, Michael. You can drive yourself.
All right, this will be a very quick update of this long and boring, but I hope useful draft. Quick reminder of what it is. Only one slide. It's a 3-pass document. We have, the first pass is taking text from existing RFCs that describes how an application would use a certain protocol. So that would be socket. Well, some RFCs talk about socket APIs. Even some RFCs have an abstract API definition. Some RFCs only discuss how you would use something. All of that text that relates to how an application uses something, we use as a basis to derive primitives in list 2. And then these primitives are supposed to be useful when you construct an API for a TAP system. They already have become useful. We have already actually begun doing this. I mean, we've done it already in Neat with the set that is currently in the draft, or the previous version of it. And then from that, we have a third list, which is the list of the derived transport services. That's an easier to read list than all the primitives with parameters and everything, just like an overview of all the services and what they are. It's easier to handle as input to the min-set draft. And it includes static properties that wouldn't be visible just in these properties. For instance, congestion control is an example. That's something that's never written as an optional feature or anything that you would turn on or off in an algorithm. Or like in a primitive or in an abstract API or whatever, but it's just a static part of TCP. And when you put all these things together and you list them, then it becomes kind of obvious. Okay, you have send and you have send, but it's a different send, right? In the sense of congestion control being there or not. It's one example. So the actual update. What's new? I mean, there's this document by Gory and Tom about UDP, and that followed the same method to make a list regarding UDP and UDP Lite. We agreed now to make an update, so he has made an update where he has removed step 2 and 3 from his document. So it's just this overview of what the RFCs say about UDP and UDP Lite, so that his document is now like an educational document about UDP Lite, whereas the stuff that takes it forward for making this longer list of services that has come into our draft. So step 2 and 3 now include UDP and UDP Lite. Then SCTP was just the base SCTP spec until now. Now it includes all these other RFCs that extend SCTP. It's quite a bit. Many thanks to my co-author, Michael. The other Michael. And so all in all, we have TCP, MPTCP, UDP, UDP Lite, and SCTP in there now. There was a plan to add DCCP, but that was input that I never really got. At this point, I would like to ask the group if we can leave it at that, or if you think we should add any other protocol. I would like to leave it at that, I think, just to be able to make progress.
Hi, Michael. Brian Trammell. I was looking forward to the chance this week to actually disagree with you.
Yeah.
Although I don't think I do.
Been a while, yeah.
So I think for the scope of this draft, I think we leave it at that. But there was one very important thing that came out of the TAPS transports document, that none of these provide integrity, confidentiality, or
Right.
authentication, which
Right.
are 3 very important services. So how do we handle that?
So we had there was a pretty long, there was much debate and discussion internally about this. We had, it culminated in Naeem as the main editor of this thing, taking contact with the chairs of, who was it? Was it chairs of some security group?
TLS.
TLS chairs.
Mhm.
And I think they were. I don't quite remember. See, the thing is that Naeem isn't here because he got food poisoning yesterday. He went to a restaurant that he shouldn't have gone to.
If I recall
he would've
correctly, Michael,
Been able to
what
relay
happened
who
was
exactly.
we sent a message to the TLS chairs who forwarded it to the TLS list asking for help, and we didn't get any additional
Crickets.
help.
Okay.
So it did go to the list. Okay.
I believe
Yeah.
so.
So that's why we gave up on it, because it was hard to
Seems
integrate.
desirable, but we don't have the expertise in the room.
Yep. Is there a paragraph in the draft mentioning that they're important but not covered?
No,
Right.
but that's easy to add.
Yeah, I think we should add that.
Yeah.
Tommy Polly.
Can the
Apple.
note takers make sure that gets into the minutes as an
Yep.
action?
Yeah.
I can send a paragraph actually.
Yeah.
Yep.
Happily.
Even
Thank
better.
you.
Great. Hi, Tommy
Hi.
Polly Apple. Right. To that end, yeah, looking at this list, I think if we want to limit it to kind of just like the traditional transport things, then we should explicitly say that. I think going forward, there will need to be a list somewhere of the other things that we get from TLS, and as you're doing streams over things like HV2 and Quick,
Yeah.
and like they kind of are taking on more of those characteristics. And so we should just maybe have a note like that will need to be done sometime.
Okay.
Because I think there are patterns that we have found that like you need those in there are similarly common patterns for when you're doing transports that are secure. That can be out of scope, but
Yeah,
I think it would be a document like this.
Yeah. Okay. Thank you.
Lars Segert, I'm not saying you should add something to this list, which is probably going to make you happy, but so have you thought about something like flute and whether your representation can capture what it offers?
Isn't multicast that's multicast,
Yeah.
right? There's a multicast is
It's
out
there-
of scope of tabs
Okay.
for simplicity reasons.
So-
early decided in the BOF.
Right. So, and I'm not saying we want to revisit that discussion, right? But I'm kind of wondering if we're doing a representation here that can, it's really limited by the choice of protocols we make here, which are all kind of similar.
Yeah. Well, I mean, my hope was that because SCTP has been kind of the protocol that takes everything on board in a way, or lots of stuff, right? That we will cover a broad set that might even be ready for, or kind of
Get ready for
compatible to
Quick.
Quick and
Get
things.
ready for Quick.
Yeah, but is it really adding many services that the
Yeah.
application would see that SCTP doesn't have?
I
don't
think so.
I don't think so. But we can have a
Well,
conversation
SCP
about
doesn't
that.
have simultaneous multipathing, and Quick will.
Well,
At
that's
least
the
not
only,
as-
yeah, that's the only thing. Okay, but we have that covered with MPTCP. Next.
You're very.
I mean, we can have
okay.
a conversation about it, but
If you're very
I would
confident
hope
about
it's not-
that, then-
No, I'm not very confident about it. I hope that we cover that, because anyway, we have to work with protocols that already exist as in specs, right? So
May I
Yeah.
fill in? So Flute is in the other document that we just finished, so we discussed it at least. It's not that it disappeared completely, and it's one of the cases Brian mentioned.
but is your point that this should be covered in this? Okay.
Lars said, did we think about it? We thought about it. Now we're publishing it. Now we're going to forget about it. Mitch?
Okay, my
Yeah.
name is Yoshi. I just try to say, my comment is very simple. MPTCP now try to, use adapt API as a working group item. So if you cover MPTCP, please be aware. So try, and then try not to make any conflict or overlap. Just simple comment.
I'm not sure I fully caught what you said.
Because
what
we are
is it?
trying to, publish API draft. So if you
All right,
cover
yes,
MPTCP,
API of, yes, I'm aware of that. So
so please
are
be
you
aware. That's my-
saying we should wait for it to be included? Because the thing is that this, I mean, from what I've seen, this API draft is about being able to control opening and closing subflows, right? So while SCTP doesn't allow you to send across multiple paths in parallel, you do have control over these things. So we have primitives in there already for opening and closing,
Yeah,
you know,
my comment is just
multiple connections essentially.
Okay, my comment is just be aware, and if it's not the overlap, if there is no
So
conflict.
I'm aware, but I would have thought that it wouldn't actually add anything to this service list because of these things from SCTP having that. But
So to that point, Tommy Polly, having kind of worked on some of the new MPTCP API ideas with them, I think probably the relationship of that to this is, as they're doing the MPTCP API work, they should look at this and look at what TAPS is doing on API for like guidance in how the API should be designed. I don't think it'll add anything different into here. This is kind of extracting the semantics that they should be using.
Okay.
So we should be aware both ways.
I mean, it's just that SCTP already has all kinds of control over, you know, different interfaces. Okay, next. Sorry, I'll do this myself. Talking to myself here. That's the last slide. About things that we think. So I think I would say, you know, hearing that we don't have to add anything major to it. Thank you for this. I think we're soon reaching the end with this draft. There are some things that we authors would say are still missing. Well, one thing, first of all, at some point in time, at least in these rules that I've created for myself, you know, to limit the work on this draft, I said that experimental RFCs are out of scope. So that would eliminate all of MPTCP, which so this rule no longer exists, and we made sure that it's accordingly covered with the SCTP and UDP and so on RFCs. But that means that TFO in TCP is a part that really should go in there because it has an impact on the API. I haven't done it yet, but I will. I have a question about whether there will be any other experimental TCP RFCs that have an impact on the API that I might have missed. I don't know of any, but if anybody, you know, would know of any TCP thing that influences the API but is experimental, then tell me. That would be good. Yes.
Hi, it's Dave Dolson. I just took a quick look, so I don't know if it's in there or not, but TCP allows you to, like, I think it's called, you can bind to any, which lets you, you know, accept addresses that are to be a foreign address. Is that something you would cover?
Yeah, yeah.
Is that mentioned?
But that's always been in the base spec of TCP. That's not an experimental addition or anything.
Sorry, I meant in the capabilities of the.
Yeah. Well,
List,
that's covered because we covered the base stuff. So that's there.
Wolfgang Beck. There's one thing I wanted to see and I didn't find it, is to query the send queue length or stuff like that.
Query the
send queue length. A real world example, we had a zip server doing lots of transport over TCP. Some Ethernet switch renegotiated from 10 gig to 1 gig, and suddenly the send queue went over the top. All our requests timed out because the things didn't get actually sent, and the application couldn't see what the situation was. So
you mean the buffer space above
buffer space
TCP?
was
TCP send buffer,
and the rate of draining the buffer space took too long for the requests themselves. So
I would agree that this should be a part of the TCP spec somehow, but it isn't. So there is no RFC describing this, and we're limiting it to that.
Right now you have IOCTLs for Linux, but they are not non-standard.
Sure.
So.
I mean, there was a decision early on to only go with RFCs because otherwise we end up with quite a mess, right? Because there are many things that you can control and should be able to control, but that are only available on some systems, not on other. And putting all that in doesn't really help very much, I think, as a basis. That doesn't mean that you can't build a TAP system that supports these things if you want to, right?
The fact that most operating systems have some way to query the send queue tells me something that people actually use this.
Yeah.
So.
Yeah. I mean, we could have an appendix. We could add an appendix on the list of things. I think that could be reasonable. A list of things that people think are important but are not covered in any spec.
Okay.
I think that would be good, actually, because that has always been brought up, that there are certain things that, you know, are missing in the spec and would be really good. And I mean, that's maybe one part of this exercise here, that you can learn what, you know, what is missing in the TCP spec, but should maybe be there. Okay. Right. So that for TCP. LEDBAT isn't a protocol, but that's also the reason why the charter says protocols and congestion control mechanisms. So I'm not quite sure how to turn that into a primitive yet, but in a way, I should cover that, and I haven't. Then there are some minor things in SCTP that have gone missing that are in the sockets API RFC. Like, for instance, the DSCP isn't written in there yet. That's easy to add, but also this SCTP no delay. And I just want to go through that RFC one more time to see if there's some other stuff we have missing. And then there's this N data draft that I think is pretty close to working group last call, which I think is something we should wait a little bit for and incorporate, because that would be the first SCTP RFC that allows you to have priorities over streams. So it's a pretty important feature in the API that we miss out unless we incorporate this draft. And then there are some editorial changes. I mean, there's an appendix explaining how you would contribute to that document. At some point, this should be changed to say this is how the document was built, change into past tense, basically. And we did get a review regarding the security consideration section, but currently the document still says security is not yet considered. So we will, that is obvious update. Comments, questions? Because otherwise that's it from me.
I have a question for you, Michael. Are you in need of text contributions from anybody here? Are we soliciting volunteers for any of these missing things, or are you going to write it yourself, or do you have people already identified?
The stuff you have on the slide, I was going to do myself. This appendix that I just mentioned, I mean, as a result from what you suggested, having a list of some things that common implementations do, but would be really good to have, but are actually missing here. For that, it would be really cool to have contributions. I could send an email to the list asking for that. I guess I'm going to get some of that.
Yeah, sort of a follow-up on that is, especially regarding like experimental TCP things, you might want to pull the TCPM list.
Yeah. Yes, I will. I wanted to do that.
Hi, Colin Perkins, just reporting from the Java room. There's a comment that NData is essentially ready for working group last call, so it can be added. And unfortunately, my Java client only shows me the Metecho name, so I can't see who it's from. But 1827419 mumble at Metecho.
Okay.
I think there's Gori Ferros.
Good.
Gori was sending them.
Yeah, so this will be covered. It's just, I mean, we just didn't get to do it. It's also a bit long.
Okay, great. Thank you, Michael. Thank you. Sorry. Does it work? Right arrow, yeah. Let me try.
Okay, just three.
Just 3 slides?
Or 4. So
Try one more time.
Okay.
All right. Well, I'll do it by hand.
Okay, so I guess we all have the context now. This is part of the milestone 2 to specify the subset that end systems can support. And part of milestone 2 is also to give guidance. And it says that we don't have to support all IETF transport services in the min set. Yes, so we don't have minimal set, we don't have to support everything. And on the bottom here, this is based on the draft previously presented by Michael. Next slide. So we have also in the previous draft made a categorization of three items, three types of services. The functional ones that you need to specify in order for applications to be able to communicate in a coherent way. the optimizing services that you would like to need if you want to optimize your application. And then the automatable, that the services that don't have to or usually don't need to be given to the applications because the applications would know about, usually don't know about the network, and they cannot do anything with those. And these automatable are still included in the draft, but when we talk about the minimum set that is given to the application, these would not be given to the application. So you can kind of say that this is not part of the minimal set, but they're just listed for completeness in the draft. So when you look at the number of services in the minimal set, you can exclude those automatable services. Next. So the changes from the previous draft is that we have incorporated all the changes you just heard from Michael in his draft, and then we now include, of course, TCP and UDP Lite is added, more on SCTP and MPT CP. And of course, we plan to, when the previous draft transport usage draft is updated, we plan to update this draft accordingly. Next slide. Yes, just a note on some part of security authentication. We have divided the authentication services in two. Some part of the authentication is functional, whether you want to have it, it's functional, and the key you use is of course functional. But another part of the services is optimizing, meaning if you don't want all chunks to be authenticated, then you can turn that on and off and tell what chunks you want to be authenticated. And that's of course optimizing, because if you don't authenticate all, it might be it might be quicker. Okay, next. So an obvious question now is, should this be a working group draft? I guess we can discuss that. And yeah, other questions?
Show of hands on who's read the draft. I can't see half hands. I can't see any hands. I see one hand. Two. Michael, have you read the draft? Will you raise your hand? Okay, yeah. Okay, plus one on the Jabber. Probably Gory. Of the folks who've read the draft, does anybody have an opinion as to whether or not we should adopt this for our milestone 2? There's so few of you, you can both of you get up to the microphone and speak your mind. Okay, Michael, sure. Co-author has something to add.
Okay, you have a co-author expressing the same wish, so.
Wait, we have a Jabber comment.
I have an I'm typing notification.
Yeah, maybe they went back to sleep. Okay, so seems to me, Stein, that we don't have. Oh, go ahead.
Hi, I'm Gory Fairhurst. Looks consistent to me and seems like adoptable.
Okay. Anybody want to speak against adopting this as our second document? Tommy?
Tommy Apple. So I guess if we adopted this, what direction would we want to take towards making any changes to it? Like, I guess as a minimal set, it does seem quite large. Would we try to minimize it further and try to take more, like, essentially, like, here's like the full set and we should try to cull things out? Is that the approach we would want to take with it? Is that what the authors want to do?
I was actually hoping that that's a discussion that we would have towards the end of the meeting once we had the other presentations.
So maybe we should
Yeah.
wait on that?
Yeah, I think so. I think,
Okay.
we've kind of got the sense of like what people think so far, and maybe we should just move on and we'll circle back to the draft later in the meeting and probably online when there's some more people. Thank you, Stein.
Sorry, late in the game. Mia Kulevind. It's, as Tommy said, it's kind of large for a small set, which is okay. But the question I would have is basically what's different from what we have so far? Yeah, it's just not clear.
If this is the minimal set, what are we actually leaving out to get to?
No, I mean, what's different from the API we have today in today's system? Where are the differences? Does it make a big change?
Mm-hmm.
Yes.
So Stein or Michael, you guys want to address that?
Okay, Michael Wessel. It is the API we have today. It's a list, right? And it's categorizing things into what you could, what you really must expose, or otherwise you will never be able to use it. What you must expose if you want the application to do an optimization, and what you don't always have to expose. It's just categorizing things, but the list as itself isn't any shorter or anything. It's just as it is. And I think the idea would be that this is a basis. So you would say that clearly a TAP system can't offer services that are not in this list, because that's the list of what protocols currently do. And you probably want to go with the functional things as a starting point for things. Well, just to say which of the functional things do we really want to provide. So I think narrowing it down is definitely of interest. I mean, but then we have something to match against. So you could say, okay, these are functional things. Among those, it's a starting point for a discussion where you can say which ones of the functional are relevant and interesting, and which ones. So you don't discuss in empty space. What is it that somehow an application would need or we would offer? Probably could match against existing protocols. If that helped.
Yeah, Kulevind again. So I think I was actually hoping for something slightly different, because when I look at this right now, it says, for example, something that's very specific to MPTCP, and that's not what I want to have in my interface, because I don't even want to know about MPTCP. I just want to know that I want to use multiple passes and so on. So I'm not sure if we are where I want it to be at that point. I mean, I don't have a good advice where to go here, but I'm not sure if this is where I want to be. That's what I'm saying. I'm not even sure if like removing this line is make it better or worse. So does this document give an implementer any benefit from what we have right now? Is there a reason for an implementer to read this document and then?
Yes. Okay. Yes. It tells you which primitives are functional. So if you don't provide them in your API, you will never ever be able to make use of them. It tells you which one of these are optimizing. So if you don't provide, you can't, without application-specific knowledge, automatically do something about them. So I think this categorization is what it's about, and that's what has value, to be able to identify which ones they want to expose and which ones they not want to expose. That's all it is.
Stein Jessing. And if you want to have the draft shorter, I mean, we can take away the automatable, because they are not supposed to be exposed to the application. Then you get a shorter draft. Yeah.
Hi, Brian Trammell. I've read the draft now, like not completely, but enough to have an opinion and be able to back it up with text. So now we have the minimum set, and we're talking about, okay, well, maybe we can take the automatable parts and pull them out, and then I had actually two windows open, and I was looking at the TAPS transports usage draft and this draft next to each other, and I'm wondering why sort of the things that are listed in this draft aren't just sort of additional information in the TAPS transports usage draft. Why isn't there just a column that says this is in the minimum set and is non-automatable, and this is in the minimum set and is automatable? That's actually asking for, because I think this minimization exercise is useful. I think it can go a little bit farther, and we need to. That's a good point that Michael's head shake made. That we don't want to say, okay, we're going to make a judgment as the working group that the automatable things are things that you should never expose, or that there are things that you should always expose. But I think to give that information, it basically just sort of becomes additional columns on each of these properties that are in the TAPS transport usage draft. So I'm wondering if we could basically take this work that was done and merge it into that draft. So it wouldn't be something that would result in two RFCs, but would make the TAPS transports usage draft useful for people trying to find this minimum set.
So I don't care how many RFCs we publish. So if that makes it easier to consume the information, then
as a consumer of this information, I would find that easier. That's just a personal opinion.
Okay.
Tommy Polly, I would agree with that it feels like it is a fairly comprehensive list that matches the usage one. So folding the current notation into the usage would make sense. I still think there's probably room for a more minimal subset draft, but like to the point of that Mira is making of like MPTCP, and like I don't want to have to know that I'm multipath, and so should a multipath aspect of the API be part of the minimal set? I think, and this may be getting to some of the stuff we're talking about later, it'd be interesting to look kind of like creatively at how we can specify this, because this current minimal set is kind of going off of the current semantics of here's how I set the socket options to set these things. I think there are certain aspects of like MPTCP that can become implicit and can be folded into some of the existing semantics and say that, oh, if I'm using, we could come up with a smaller set of common things that can be interpreted per protocol more intelligently and end up with a smaller overall set.
Mayor Kulevant, I guess I'm adding directly to this. So I think the interesting part about this draft, which is like more related to Charter Point 2 here, is the automated part, like giving guidance on how to do the automation. If you don't want to expose this part, what do you do instead? That's the more interesting part for me here.
Michael Welzel, we have begun adding some text about that to that draft. So that draft has some text about how you would do it, but not very much. I mean, I definitely would think it should be extended with it. Should also be narrowed down at some point to, this kind of, I mean, I see this in a way, if I look at the TAPS users draft, which has 3 passes, I also in a way see what we have there now as pass 1 of this minimization, right? You categorize it and then you do more stuff with it. You have to explain how you would implement one with another. You would explain on which basis you would pick some of these things. It's how I view it. That's what I'm saying.
Mia Kuhlmann again. What I would like to see is, I think the categorization could go into the usage draft, and then the stuff on automatization could be a separate draft.
So I wouldn't have a problem with that. It just makes it a bit long, but it's okay with me. Yeah, it's already long. Yeah, it's getting even longer, but yeah.
I suspect this discussion is going to come up again later. Let's move on with the agenda. And but I think this was a good conversation. Yeah, I think we're still kind of figuring out what's going to go into this second document. So let's try letting Colin start again.
Okay. Hi, my name's Colin Perkins. I'm from the University of Glasgow. This is work which has been done with Stephen McQuiston, who's one of my students, and with Marwan Fayed at the University of Stirling. And we've been looking into what it takes to, or what sort of transport services would be appropriate for low latency applications. Next slide. So our goals here were really to try and take a sort of top-down view, look at what the applications need for people writing, streaming video applications, interactive conferencing applications, augmented reality gaming, this sort of thing, which is very time-sensitive, very latency-sensitive applications, and try and think what services and those applications need and what sort of abstract API they need, and try and derive this rather than from looking at what the existing protocols provide, derive this from what the applications need. So sort of approach this from the opposite direction. It's the basis for a piece of work my student is doing called TCP Hollywood, which is something we're not bringing to IETF because it would raise Joe Touch's blood pressure way too dangerous levels if we did, because of the things we're doing with TCP. So that's not something I particularly want to talk about here, although if you're interested, go read our papers and cite them widely. The concepts, though, are hopefully a little more general than that project, which is why I want to talk about them in TAPS. And I think it's taking a different approach to solving the same problems, or very similar problems to what TAPS is solving at the API and services level.
It's a little hard to hear you from behind. Would you mind getting a little closer to the microphone, just because you're facing the other way?
Yeah. Yeah, I have to sort of get way too close to this microphone.
Yeah, sorry about that.
Okay, so in terms of services, I mean, we're looking at building real-time applications. The essential characteristic of these applications is that they care about timing. Right? The application data has some sort of lifetime from which, after it's generated, before which it must be consumed. Depending on the application, that could be a small number of milliseconds. I mean, if you're building a telephone, then that's on the order of tens, maybe 100, 150 milliseconds, sort of maximum latency before the conversations get awkward. For streaming, it's maybe a second or a couple of seconds. For some of the augmented reality, some of the gaming applications, again, it's on the order of tens, hundreds of milliseconds. So timing is important. It clearly makes no sense if you have a very time-critical application for the transport protocol to be sending data that's going to arrive too late to be useful. That's just a waste of capacity. In order to design a transport that then makes good, that's then appropriate for these applications and reflects their semantic, the transport needs to know the timing, the lifetimes of the data. It needs to know something about, okay, when is this data generated? When does it need to be delivered by? So it can avoid sending stuff which is useless. It also needs to know some estimates of the network transit time, or at least the round trip time, so it can approximate the network transit time. And it needs to know something about how much the data is being buffered up at the receiver. So again, so it can figure out, is this data going to get there in time for the receiver to use it? And if not, it can perhaps decide not to send that data. And it needs to somehow schedule the transmission, the data transmission, being aware of the timing, and somehow expose this information to the application so the application can specify the timing and the deadlines of the data in what it's passing into the transport. Next slide. So the essential service is timing. We're running, however, over an unreliable, or at least a best effort network. A consequence of that is that it may not be possible to meet the timing gap, the timing constraints. The network is unreliable. It means data is lost. It means that the transport has to recover that loss, either using some form of forward error correction, which is imperfect, or by retransmitting the data. If you retransmit the data, there's always the possibility that the retransmission may be lost. Therefore, you need to retransmit the retransmission, and potentially again and again and again. And a consequence of this is that if you have any network which can ever lose packets, which is essentially all of them, there's no guarantee that you can always meet the deadlines. That means that the transport has to be at most partially reliable. It has to accept that if you're dealing with real-time data which has deadlines, it may not be able to meet those deadlines and may have to discard the data because it can't meet them. It can't meet them It either is reliable, in which case it misses the deadlines, or it's unreliable, in which case.
That's exactly my use case I described before. And my solution would be not to leave it to the transport layer, but to the application, and give the application the opportunity to see if the queue already is so long that my deadline won't be respected. Because the application layer never can guarantee the deadline.
Yeah, I mean, this is what current applications do, is that they use an unreliable transport to manage retransmissions themselves if they need to, or they use reliable transports that accept that they may miss their deadlines. We tend to think that that's an ideal transport. The application could just say, deliver this if you can do it by this time. And if not, I accept that you won't be able to deliver it, and that unreliability is okay. And the current transports don't really seem to give that option.
Yeah, but TCP cannot guarantee the deadline.
Yeah, I agree. TCP can do this. Yes, that's true.
It doesn't know if the message arrives or not. So
yes, I agree. And we're not describing TCP. We're describing what we would want an ideal transport to do. And yes, TCP does not meet these requirements. I agree.
But I'm looking at the application protocols which only know unreliable or fully reliable protocols, and zips, for example. And if you have a partially reliable protocol, you would have to redescribe the application layer protocols as well.
Yes, absolutely. Yeah. Yes, I mean, we're looking from the point of view of someone building a new application to address these real-time. You're building a new conferencing application, for example. What would you ideally want the transport to look like? And you would want the transport to know about timing, to accept that, okay, I will try to deliver this data by this deadline, and if I can't do it, that's okay.
Right. Yeah. Kyle Rose. Like if you are designing a real-time conferencing application, probably the behavior you don't want is for the stream to just drop if it can't get there within your SLA of 100 milliseconds or whatnot. Right.
You don't want the stream to drop. You want it to drop the packet and say, okay, I can't deliver that packet, but I'm kind of going to keep delivering the rest of the data, and rather than doing what TCP does, which is block until it's delivered that one packet, which is going to be useless anyway, because it's missed its deadline.
Agreed. Okay.
Yeah, I mean, we're not saying drop the stream, we're saying drop the packet. Yeah. Next slide.
Next slide.
Okay, so we accept that we need timing information, and as a consequence of that, the thing will be partially reliable. Some data is going to be lost. Given that, we typically in these applications have data which is not independently useful. Right. An example would be an old school MPEG codec where you have an iframe and then a bunch of predicted frames following it. As a consequence of that is that you want the transport protocol to be able to track the dependencies. So you can say to the transport, this data depends on this other data, which I have sent earlier. And that means you can either build a transport so you want a transport that tracks these dependencies, so it can either avoid wastefully sending data which depends on something that's been previously lost. There's no point sending an MPEG P frame if the iframe has been lost, because it's not going to be decodable anyway. Or the transport could be smart enough to say, well, this iframe isn't going to arrive in time to be rendered, but I'm going to send it anyway because the P frames that follow it will arrive in time, and I can decode it and use it to decode the rest of those frames. So if the transport, so we want a transport that is timing aware, partially reliable, and tracks dependencies, so it can make intelligent decisions about what it drops and what it doesn't drop.
Michael Wells, would you like a question now or later?
Entirely up to you.
Okay, so if you don't mind, so this is something, I mean, I read the draft and I read the other related draft as well, and I think both drafts cover things that are already covered by, at least by SCTP, except for this dependencies thing. And I'm wondering if dependencies is something that a transport really should take care of, or if it should be more like this, if you would have this TCP low watermark type thing, where you just have a very small buffer inside TCP and you let the application take control of these things, then you wouldn't need that in an API because the application takes care of it. So the question is this, should it be like this or should it be the other way?
I mean, you can build all of this in an application. Yeah, I mean, in the worst case, you could just run over UDP and you can implement all of this in an application. And lots of applications do exactly that. My feeling is that it greatly simplifies the application if the application can say, here is some data, this is when I need it by, it depends on all of these things, and please go away and deliver it if you can, and if not, tell me what failed.
And it's a relatively general thing to encode. You could just give numbers and say, okay, all these things depend. So I agree, but
and mostly it just says, you know, this message with sequence number 6 depends on message with sequence number 3.
Okay.
And
so I'll just note that's the only thing that is I think that isn't currently covered by, for instance, SCTP, because it just doesn't do it.
Partially reliable SCTP is pretty close to a lot of it, to what we're describing.
Yes. The priorities, you mean, or the priority-based method, you mean, or because the other, I mean, you have timing-based, you have priority-based, or you have based on number of retransmits. And I mean, the first one, the timing-based, would match your timing-based partial reliability, but the dependencies.
Yeah, I mean, I don't think there's anything that does all of this. I think there are some things that come fairly close, and PRS-CTP is probably the closest.
Yeah. Okay.
Yeah.
Thank you.
Or you could use TCP Hollywood. But,
Wolfgang back again. So the API would expose an event where the sending operation could not be done because of the deadline, or?
So the API has, as we have suggested it, is a very minimal extension to the sockets API where you write data and you give the data an identifier, and then you say, well, and then when you write again, you say, well, this depends on that previously sent thing. It doesn't expose what does or doesn't get sent, but the transport will know, okay, if I haven't delivered this, there's no point sending this other thing. And it just makes a priority decision on what to discard.
Yeah.
It allows it to send something which to sort of, if it's got to drop something, it allows it to choose to drop something which is not going to be useful at the receiver anyway. All right. Given this, in order to make the data useful at this point, you need some way of splitting the data into application meaningful units. So you write a message, and that message gets delivered as a whole, rather than writing a byte stream and not knowing where that's fragmented. We're tracking timing and we're tracking dependencies, and we're discarding data. That means you need to be able to say what are the boundaries of the data units. So it's smart about, here's an object which has a name, and I can refer to it for terms of timing and dependencies and so on. That means the API and the transport services must respect message boundaries. We want a sequence of messages rather than a byte stream. And that means once you've got all of that, you've got timing, you can identify messages, you can track dependencies. That means you can do out-of-order delivery. That means you can process messages out of order. You don't have the head-of-line blocking problems that you have with TCP, because it's delivering whole messages when they arrive. Once you've exposed message boundaries, once you've exposed them in the transport and in the API, that allows you to easily do multi-streaming and have multiple streams multiplexed over a transport, because you know where the different data units start and end, and you can decide, okay, you know you can multiplex them, you've got length fields there, and you can distinguish the objects and pass them to the right places. So that means that the message boundaries need to be delineated, the message needs its own identity, and you need to add a subflow identifier, but that's easy once you've got messages and so on. And again, the API and the transports must expose these substream identities. Right? Now, this is not a critical feature. There are a lot, you can just open, if you've got multiple flows going to a given destination, you can open multiple transport connections. There's obviously an efficiency benefit from being able to put them all into a transport and demultiplex, and lots of transport protocols do this. At least for these type of applications, coming from the real-time conferencing world, the motivation here is that the NATs and firewalls just interfere with opening multiple connections, and that the more connections you try and open, the more likely it is that it won't get through the NAT. So if you can multiplex everything over one transport, that works better. Next slide. And again, once you've got multiple streams, once you've got multiple messages, it's a pretty straightforward, pretty obvious extension to say, well, we've got multiple streams, we've got multiple interfaces. We don't have to multiplex them all down the same point. We can run them in a multipath transport if we have one. And yeah, that's difficult.
On the receiver, Oscar Erickson from Chelsea. How does the receiver? You said that it's partially reliable. So how does the receiver differentiate between packet lost and it's too late to receive this packet?
So the question, if I heard it right, was how does the receiver distinguish between packet loss and too late? I mean, essentially it doesn't. I mean, the data doesn't arrive at the receiver, and whether that's because it was lost in the network or because the sender decided it wouldn't arrive in time to be useful.
But at the same time, you say it's partially reliable.
Right.
So then the receiver is acting on occasion. So how does it know that?
Sorry, I can't hear you. You'll have to talk into the microphone.
Yeah, so, but at the same time, you say it's partially reliable.
Right.
So sometimes the receiver is then acking packets, but sometimes it's jumping ahead and accepting a packet as a good packet. I missed how the receiver stays in sync with all these assumptions and timing on the sender side.
I'm not sure I understand the question. I mean, the receivers send ACKs for the packets they receive would be my guess. Although I mean that's not.
Why isn't this UDP? Like, what's different from UDP?
What's different from UDP is that the sender can retransmit things.
Yes, but the receiver acknowledges the receipt of packet, sends it back to the sender. But sometimes you have congestion so that you fall behind and you throw away packets. Then you have to tell the receiver somehow that, yes, jump ahead by the same amount.
No, I mean, the packets arrive with timing and sequencing information, and the receiver can make use of them as they arrive. If they don't arrive, the receiver can't make use of them. Yeah.
Okay, so it's the timestamp that helps the receiver to stay in sync with the sender.
I'm not sure I understand the question. Sorry.
Can I suggest maybe if you have questions after the talk that you talk offline?
Okay.
I'm a little concerned about the agenda time.
Next slide. Okay. Other things. I mean, obviously, you need to take into account network overload. The congestion control. You need a congestion controller, and that needs to take into account data timing. As well as throughput. It needs to pay attention to whether the data it's sending will arrive in time to be used. So that may affect the decisions, not for how much it sends, but for what it sends. And we can certainly envisage APIs that expose a much more cooperative API between the application and the transport in terms of congestion control. Lots of these types of applications, for example, are very non-elastic in when the data has to arrive, but can quite happily change what gets sent. And that's very different to a traditional TCP application, which always sends the same thing, but doesn't care about when it arrives. So maybe the API and for congestion control is a little different. And finally, we've talked about connections. Obviously, having per connection metadata is useful. It's useful for maintaining the security association. It's useful for maintaining NAT bindings, things like that. However, a lot of applications have connections that outlive a single transport layer connection. If you're making a phone call, for example, and you're moving around, your IP addresses are changing. You're running on different transport connections as you roam around. Yeah, it's the same phone call. So it's useful to sort of expose, we need to distinguish between a particular instance of a transport connection and the long-lived state for the communication between the endpoints. And it's useful to somehow be able to separate those out, I think that makes things easier. Okay, so we took this deep dive looking down from the application requirements, starting with the fact that we need timed data and the implications for that, which are that we have partial reliability. The consequence of that is that dependencies are useful, which means you need a message-oriented transport, and that allows you to build multiple streams and multipath and all of these things on top of it. There aren't, as far as I can tell, any existing transport protocols that do all of this. Some of them come pretty close, some of them are pretty far away. Similarly, the existing APIs don't really expose all of this. Again, some of them are pretty close, some are pretty far away. In the draft, we've sketched out a very minimal, very half-baked extension to the sockets API that exposes what we needed for the particular piece of research we were doing. But to fully address all of the things I've been talking about, we need a much more significant API change. And I know Brian has the post-sockets talk later, which will suggest one such API, and I think Tommy has been talking about something similar. So there are people talking about these APIs, and we've been having some discussions about that. The question is for this working group, are the things we have identified actually sort of listed and exposed in TAPS? I think most of them are. I think it's a pretty good fit for what TAPS has come up with, although it's not the same list. And perhaps a conversation for later is, should TAPS be considering this sort of abstract API work? Although that's probably something we should discuss after the later presentations. Thank you.
Hi, my name is Kyle LaRose from Sandvine. I may be completely off base here, but your comments about timing and reliability made me think about the DetNet session I attended the other day. They're working on building up a network that is extremely reliable, guaranteed timing, bandwidth, things like that. Is it the place of this working group to help define a transport that could make use of these lower level features?
I don't know, but I think if we are designing new transports and new APIs, it would make sense that they could at least work with those features. Yeah. I mean, there should, if people are designing new networks, I don't think we can require those networks, but we should be able to make use of them if they exist underneath us.
I mean, maybe out of scope for the charter because it seems pretty experimental, but something to keep in mind.
Yeah, absolutely.
Spencer, do you want to respond or should I?
You go first.
It's out of scope for the working group. What we're doing is we're talking about sort of the interface between what applications want and what transports provide. Now, maybe that applications can ask for things that, particular transports, say one of your transport uses RSVP, and then it can talk to something the network can provide. So it's related to, but it's not something that we would develop in here.
Okay, so Spencer Dawkins, thank you for going first. The thing I would say is that there is an awful lot of interest in the general low latency, low delay topic in a lot of places, and people wanting to use DetNet and things like that. I'm thinking that that's going to end up in transport someplace. Whether this is the right place for that or not, I couldn't say. This is a thing where we look at a charter proposal and see where, see what makes sense. But that is something that I'm paying an awful lot of attention to in general. Thank you.
So help me God, if you turn this into a quality of service working group, I will walk.
I mean,
just kidding.
Thank you for that input too.
I think it's clear that the transport people need to talk to the lower layer people. Whether this is the right place or not, I don't know.
Kyle Rose. So there is a fine line between quality of service and what's being proposed here, right? So for instance, if let's take the video conferencing situation. If you're trying to have a video conference with somebody on the moon, right? Your hand waving latency is like 2.5 seconds or something like that, right? So if you set your SLA at 100 milliseconds, you're going to drop everything. What you really want is to say, well, within the realm of what's possible, I would like this like level of quality. And if it's below a certain latency, then give me perfect quality, ideally. I don't know if there's any way to express that in a generic way, or even if it is useful to talk about that problem in this room.
But the first stage of that is for the application be able to say these are the requirements. I need you to deliver this within X milliseconds.
Right. So then it's up to the application then to determine some of the properties of the path, right? Because it can obviously do probing and determine, oh, well, you know, the minimum latency for this is 2.5 seconds, so I probably shouldn't ask for 100 millisecond guarantee, right? But what I really want is if I can get 90% of the packets through, that will provide me with good enough with good enough quality, minimize my latency on that basis. Does that make sense?
Yeah, I mean, the application needs to say what it wants, and the transport needs to be able to say, I can or can't do that. And then there's a very difficult API about what happens if this is or isn't possible.
Right, but it's not necessarily static, right? Let's say your direct route between the Earth and the Moon goes down, and so you have to bounce through Mars, right? It's going to take a lot longer for your packets to get through.
Sure.
Maybe at that point you want to bump an error up to the user and say, yeah, you know, your real-time chat's not going to work, but.
Absolutely.
Michael Welser, regarding the question on how we would possibly implement that kind of thing. I mean, obviously, yes, we're not chartered to do a new transport, but I do not think we would need that, you know, based on the current set of what, for instance, SCTP provides to do these things. So, I mean, if, as I suspect, the only thing that's really missing would be the dependency stuff, that's a pure buffer management side, on a one-sided buffer management question, right? So we have this item where we're going to explain how a tap system would work, how you would implement it. Could include text saying, well, in your buffer, if you run over a partial reliability transport, if that transport tells you that this packet has been dropped, then you should also drop away the following from the buffer, and you should expose that in the API in the following way. I can't see why that wouldn't be something we could be describing.
Yeah, I mean, I think it's very easy to implement this over UDP. I think it's easy to implement it over SCTP. You can't implement it over TCP without hacking TCP. Yeah.
There's someone waiting on MeetEcho if you'd like them to go first. I think they've been waiting longer than me.
They were waiting longer?
So.
Okay, I think I pushed the red button. I've never done this before. Go, Michael.
Very good. Hello, Colin. Michael Ramallah, Cisco Systems. I'm going to ask a question that I think was partially asked earlier, and I'm looking at this list and I'm thinking about partial reliable version of SCTP. Has most of these things, chunks instead of messages, but streams, paths, congestion control, connections, has partial reliability, doesn't have any sense of timing relative to telling the application whether or not it can make a certain deadline. But the only one that pure SCTP other than timing doesn't seem to have is a dependency. We generally don't say that this chunk in this stream, be it reliable or unreliable stream, is dependent upon another chunk, or in your taxonomy, a message that's in a different stream. Other than that, other than the timing and the dependencies, is there anything other missing or that you're proposing that's outside of a partial reliable version of SCTP?
Hi, no, I think PRSCTP is pretty close to what we're describing here. Yeah, absolutely, that's the closest we've seen so far.
Okay, thanks, Colin.
Okay, Jahed from the floor. I mean, looking at this conversation and looking at this, what we have been discussing here, I kind of get a feel like, well, this is not only the thing that application just fires to the, tells the transport to do and it forgets about it. It would like to get a reply or a kind of sense of like what's happening in the transport. But I don't know, like your document really says that in an explicit way that these TOPS as a service provider also need to talk back to the application. And basically, I would also like to ask the transport, the TAPS working group, what they're thinking about those kind of things, because all I am hearing is like, I want this, I want that, but what actually I'm getting, how this feedback goes back from the transport service to the application.
Yeah, I mean, as we say here, right, we need a radical API change if we're going to really expose all this and have the right sort of level of communication. Yeah, very much agreed, and I think we've got a couple of proposals for that coming.
Yeah, I mean, this is also like, I think Tommy had a comment like, well, I don't need to know if it's multi-path or not. But in some applications, you may actually want to know, and you would like to know like whether I can guide the transport actually to do something about it. All right, so
yes.
Yeah, those kind of information is like had to be bi-directional. It cannot be like just tell the transport and transport does, and you kind of guess like what transport is doing.
Yeah, I mean, yeah, certainly the type of APIs I like are the ones where I can tell the transport, I can query what the transport can do and then it influence that rather than I say do this and magic happens.
Tommy, just in response to that.
Okay, quickly, there's somebody in line behind you, but.
Oh, there, sorry, my bad.
Yeah.
Jonathan Looning, work for Netflix. I can give you a use case for this sort of thing. When you are trying to deliver content at very high scale, it's very important for the application to touch sessions as little as possible. And so the application layer needs to be able to dump a chunk of stuff to the transport layer and then forget about it. However, as you've mentioned, there's times when if the data doesn't get to the client soon enough, then it's just not useful because the client is going to enter a cycle of ignoring that data and instead asking for a lower bit rate, for instance, or just saying, hey, wait, we need to restart from scratch or something. And in those cases, it's actually counterproductive to continue to try to send the same data from the transport layer. And it would be, again, when you're delivering stuff at high scale, it's very important for the application to be able to have to touch the session as little as possible. And so having the transport layer automatically take care of, it's not going to get there, forget it, just don't bother sending the rest of it, is extremely important and extremely useful. I don't think it takes a radical API change to do this. In fact, I think I would say you probably could even get away, at least in the use case I'm thinking of, which of course is very self-serving. I think you could even get away with not even notifying the application that the delivery failed and leave it up to the client to itself tell the application something happened, you need to do something different. So I think it's, the bottom line is it's a very important thing and potentially very useful to be able to just have the transport layer know automatically, I don't need to send any more of this data because it's not going to be useful by the time it gets there.
Thank you. Yeah, I mean, I think I would agree with all of that. I think the more radical API changes are more critical for things like very interactive conferencing, right? Where you're adapting what you're sending based on the precise details of what's happening on the network.
Right. Yeah.
So just after Tommy, there's nobody else up, but I want to cut the line here and then have a short conversation about what are we going to do. So go ahead, Tommy.
So yeah, just talking about the feedback. I think that the feedback is very important, especially for these cases. With regards to both this case as well as the MPTCP case, before we were having a conversation about like the minimal subset. So I think the minimal subset can leave out feedback because the application may not care. Right, and then in terms of like the specific APIs that you would want for reading, writing, I think it'd be interesting to make sure that if we're looking at generic new API forms, something like having something that would work for traditional transports as well as this would be great. So like the type of semantics which you have a write and then a write completion that can give whatever arbitrary data the protocol has for you.
Yeah, that makes sense.
So want to talk about what we're going to do with this. And in the context of that, I just wanted to pull up the charter here. So as I recall, Okay, it's not in here. So basically, what we've done is we've identified something that's not supported by the current set of transport protocols that seems like it would be useful to have in a TAPS API. So it raises the question as to, what are we going to do with that? The current charter says basically that we take the existing standardized set of protocols, we identify the minimum set of services that those are provided, and then we look at mechanisms for a what a TAPS layer would do for assembling and probing the availability of these protocols. So now if we're talking about adding something new that's not supported by the current protocols, my sense is that's out of scope for our current focus, but I don't want to lose this because it seems like it's actually a very useful thing. So let me just sort of throw this out here as a straw man for what to do with this. We turn this message dependency service into a standalone draft. I mean, that's my takeaway from the talk of sort of the missing piece. If there are other missing pieces, then I think we would want to address those as well. But write it up as a draft, continue on with the TAPS work the way it is, get to the point where we're working on milestone 3, and then circle back around and start to ask the question, okay, are there other useful missing things from this API that we could add onto there? I think if we want to do something other than that, then we're talking about changing the charter, which I'm open to doing. I mean, there's a lot of exploration that's going on in this group, and we can do that. But I don't think that's really where our charter scope allows us to do now. So let's try to take just 5 minutes to talk about this if anybody has any opinions on it. So please be brief. Go ahead.
I would recommend that this particular item be transferred to TSV and added as an SCTP extension. That's my suggestion. And then once that's done, you can pull it into TAPS.
Right, then it's well played. Brian?
Hi, Brian Tremble. I was going to be super brief. I was going to say yes before that. But
Yes, for what?
yes, for Aaron's proposal.
Okay.
Let's write it up.
Not
Let's write it up here. I think once we've seen a specification of that, then we can sort of make more decisions. Because I mean, like, this is not a new thing, right? Minion did this. This is HTTP2 can really use it. I mean, there's a lot of energy behind it. I think it might actually make sense to look at how Speedy did it when it was still integrated, and possibly refer to that. But having like sort of a very short document to specify what this service is, I think is super useful. I think sticking it into SCTP in the TSV working group and then having a look at this in 2020 or 2021 is a little bit slower than I want to move.
Well, once we have a draft, we can separate the writing up as a draft versus where it gets taken to. So, Spencer, I think you're next.
Actually, let other folks talk, if you would.
Michael.
Okay, Michael Wetzel. I can't say that without laughing, but again, I completely agree with Brian. And
you get used to it after a while.
Yeah, one argument for why that doesn't have to be an extension to SCTP is that it can be implemented over SCTP, one-sided, right? You have a partial reliability transport, and you just have it like so you could even see it as a way of selecting and engaging SCTP, couldn't you?
Tommy. Right, so I agree that the protocol specification or anything new like that is out of scope of this, but again, like the dependencies, having semantics around that and making sure that we look at that as part of TAPS, I think is important. It kind of falls into the category maybe of the other things that the usage documents didn't cover, like what TLS does. So if we want to incorporate into the semantics of whatever APIs we have, things that are not just standard transport level services, and say these are things that you commonly use on top of the transport that are probably behind the API boundary, like security, like doing dependencies. If your transport supports dependencies, great, but you can also simulate it over many, many other protocols. So I think it's a useful thing to not forget in our lists of features that we want to have in the API.
So to paraphrase you, it sounds like you're +1 to writing it up and +1 to making sure that something happens with this but you're not expressing strong opinion as to where or what protocol.
Right.
Okay.
If anything that's in here should be more protocol agnostic, but I think that those concepts do exist outside of a new protocol.
Yeah, that's a good point. Anna?
Yes, Anna Brunström. So I was going to say something very similar, actually. I think it depends on what we put in scope or what can be changed in the API and what is, because the API is open for defining, right? So
to do whatever we want.
Yeah, so it depends on if we see that this is a new functionality provided by the transport or if something that can be kind of integrated in between. But I think also making it as a second step, I'm fine with that as well.
So the reason that I'm pushing back on that, if you look at sort of the milestone 1, it says define a set of transport services identifying the services provided by existing IETF protocols. So I don't think this is a service that's provided by the existing IETF protocols. And the risk here is that we now set a precedent that other good ideas we can start to stick in here, and then we never get to milestone 3, which is actually implementation with some experimental deployment, which I really want to do because I think we're going to learn a lot from that. So that's the concern.
No, I agree. I mean, it makes sense to have it in a second step. But I think in general, when we have these discussions, we will have this borderline in terms of if it's an API change or if it's actually a functional change. But yeah, I would agree this is functional.
Colin?
Hi, Colin Piggins. So I'm not sure I agree that it's not supported by any existing IETF protocols. I think there are RTP extensions that do exactly this. There are various other protocols. They're not the set we have considered in this working group.
RTP is not considered.
Yeah, fair point.
So add my voice to the chorus of people saying that this can actually just be an API trick. I mean, so it's explicitly an API trick in post sockets. It's sender side only because post was designed to work over any set of transport protocols that you can layer it on top of. I'm going to actually steal an idea from Miria. This could also be seen as an experimental support mechanism, right? We want to experiment with new APIs on top of this thing. So, I mean, you could, if you really wanted to, hold your eyes just right and look at it just right and put the right light on it and find a way to wedge this into the charter. It's experimental support mechanisms is a loophole you can drive a truck through.
Right. That's why getting a draft is the first step. And yeah. So I'm with you. Okay, so now we have an AD at each mic. You guys fight it out.
I just wanted to add to this point.
This will not be a cage match. I'm just saying.
I'm not speaking as an AD. I've just been staring at this, and this has experimental support mechanisms, and I think that goes in line with what Tommy says. If you have this mechanism as something that is protocol independent, that's kind of a support mechanism we've been talking about previously.
I could live with that. Spencer?
So Spencer Dawkins speaking as the responsible AD for TAPS. Writing drafts is good. That's what we do around here. Individual drafts are a great thing, and I encourage people to write them. What we're talking about here is not in the current charter, and I would observe, without any reference to TAPS specifically, that recharter requests that say we've completed our work and now we are headed for new exciting things that there's a lot of energy behind, usually go a lot faster than any other kind of recharter request. So my suggestion, which you all participate as individuals, my suggestion is if you think this is really interesting, help finish 2 and 3.
Okay, this was a good discussion. Let's move on. Don't we run till noon? Oops. What? Speed talk. Yeah, I really wanted to get this talk in. So Zayed was telling me we were running late. I'm like, no, we've got an hour.
The next group doesn't start for another 10 minutes. So I'll take 3.
I think we have a 1.5 hour schedule, not 2.5 hours.
Yeah. Okay, all right, go.
Tommy.
Okay, so Tommy Polly, Apple. Context. So there's stuff TAPS does. There's stuff that Brian has presented last time and can present again if there's time, not time. Okay. About post sockets, which is kind of an approach of let's just look at what the API should be. We're coming from the perspective of we did our independent implementation and we think there's a lot of overlap, and so we wanted to give some perspectives on how the API should work. Let's move on. Cool, so definitions. Next one, There's a joke. So we have first endpoints that we're talking about. So addresses, host names, things that you can talk to. Next one. Okay, so we have a concept of a path. And so what I want to point out here is that from the there's a thing you want to talk to, and then there's all your parameters. But then the important part, there's also you get a result, and there's a combination that needs to happen of the client preferences and the system state. And I think that really needs to drive a lot of how we're choosing what protocols to use and how to build our stack. I think that would help solve some of the ambiguity of what do you need to use in TAPS. Next one. Okay, so here's complicated diagram. This is how we currently do our connections. If we had more time, I'd go into more detail. Essentially, this kind of lines up with the concept that PostSockets has, if you read that, of the association, although it kind of incorporates a couple more of those concepts. Essentially, the idea is that when you are creating a connection, there are many possibilities that can happen. So let's go ahead just through the different points. You can keep moving. Okay, so the main three things I wanted to point out were that whenever we're designing kind of how the client should look at this, we need to get beyond what socket does of just saying, I have this strict association in which I know I'm doing this one protocol, or you decide just one thing when you're creating the connection. There are lots of reasons for new protocols that we need to be able to support more. So point one, we need to attempt multiple things. Point two, that the things that we should attempt need to be dynamically realized as a combination of the client preferences and what the system and network state is, and that we should be able to have the protocols actually be working in parallel for reasons. So we have some details. So what does it mean to attempt multiple paths? So there's normal happy eyeballs. There are multiple host names per bonjour service. It's kind of a higher level of happy eyeballs. You have happy eyeballs between interfaces. And also, as we mentioned last time, there's happy eyeballs potentially between protocol stacks. Today, we see that primarily in when we attempt doing a proxy stack versus a non-proxy stack or different proxy protocols. But that really could be generalized to say SCTP, TCP, MPTCP, and actually start racing them. And so we want to be able to hide those kind of behind the single layer of abstraction that the client sees. Yeah, so here's just some numbers. This is an example of how our happy eyeballs works. So the way the connection would work inside is that you create, for example, a resolver based on this. So you have an endpoint, you look at its path, and it says, okay, I can't connect directly to this host name. I need to do something with it. Let's become a resolver. And so I go and I resolve, and then I race different children. In practice, we see that on 5% of connections, we end up using not the first address we would have chosen otherwise. So it is a thing that's happening quite often. Second point, you should build a path dynamically. It's not just a predetermined set of things we want to try. There's a combination, again, of client parameters, what the system has, and what the network conditions are. So here's a case of how we race protocols. Again, we start out at the very top. We do an evaluation. First thing we see, okay, I have an endpoint. Oh, look, the system has some proxy settings. It's telling me I need to try a proxy using socks. And also I can just go direct. And so we essentially do this recursive step of saying, let's try these different possibilities. Let's fall through them. And again, we see that around 7% of connections that on all of our devices are using some scheme like this. So it's an important thing to do. We also do racing between interfaces. This is often for us based on looking at the quality of the available interfaces. Let's say we have Wi-Fi and cellular. Wi-Fi is kind of bad, but we kind of prefer it. And so we want to be able to try both. So again, we generate kind of more of a tree state machine for this. And for this, when we do determine we're eligible for this, racing between these two different options ends up giving us 20% using something that would not have been what we used otherwise. And the last observation is that these protocol stacks should be in parallel. Of course, for happy eyeballs, you're attempting your TCP in parallel, but it goes beyond that. There are things that you could race TLS, you could race various parts of HTTP. And when we're doing fast open protocols, which is something I know that we're just starting to look into in this group, it's really important because in order to get the fast open data, there is potentially different application data or higher level protocol data that needs to go in the different versions of a stack, right? If I'm going over one interface that has one set of protocol requirements versus another one. Next. Right, so here's the example of that. Let's say I resolve to 2 addresses, and I'm doing like a TFO race on each for my happy eyeballs. And so I actually have TLS be involved in that. So the reason I bring this up is it's a good reason to take into account things beyond just the transport protocol when we're looking at what are the abstractions we need here, because the levels like TLS and HTTP do really need to participate. And especially like at this connection setup time, they are not necessarily representing true user data. Like TLS is still part of the hidden from application level generally. And so we want to make sure it's provided in a way that we can do really intelligent things at the transport layer with that data. And that is it. Okay, a little bit over time.
Thank you. So I apologize to the group for mismanaging the time. I'm really sorry, especially to the people who had talks that they couldn't give. Before you go away, Tommy, not so fast. So I think this is actually a much more sort of concrete approach to what the milestone 3 work is about than I've.
And this is all stuff we've deployed and are shipping. Yeah.
How would you feel about supporting a draft that captured some of these design principles and maybe sketched out some of the mechanisms at a high level?
Sure. I guess, do we want that in forms of like an informational or in terms of requirements proposed standard document?
I don't think we know, and I don't think we're going to be able to figure out in the time that we have. But if you're willing to participate, then maybe we can have that discussion on the list. Can I see a show of hands of anybody who wants to participate in developing that document? Okay, so it looks like you've got some collaborators here. Again, I'm really sorry to the folks. I wanted to hear the other talks, so so I'm disappointed about that. But the slides are posted, and let's take the discussion to the list. Is there anybody? Can I see show of hands? People who did not sign the blue sheets. Okay, somebody make sure that guy gets a blue sheet. Thank you, everybody.
Thank you.
See you in Chicago.